Hey, welcome back to Stat 218. So we're moving further into Chapter 10 today. I affectionately call this section Moron Tables. Yeah, literally, if you have a 2 by 2 table, 2 rows, 2 columns, and you see a statistically significant relationship, I think we naturally would test to see whether the rates of the effect, the rates of the side effect, if you will, are the same in each group versus whether there's a difference between the groups. And if there is a noticeable difference between the groups, you want to go on and say, okay, what is that difference? And could I put a margin of error on it? There's two ways of tackling that issue. One is with a difference of the rates. Okay, so that's like chapter 10, section 7. And then there's the ratio of the rates, or an odds ratio, in chapter 10, section 9. So 10.7, this will be a little bit more straightforward, and the first part of 10.9 also straightforward, but then the subtlety of odds ratio in the tail end of chapter 10, section 9 will require probably two viewings. So I'm going to break this down into 3 separate videos for the latter bits of chapter 10. Okay, so if you've got a 2 by 2 relationship and you see there's a difference between the two groups, you want to know what is that difference. If you want to express that difference as a literal difference, okay, if you want to say what is the difference of those two rates, what is P1 minus P2, and P1 minus P2 is not always the most straightforward way of expressing things, but a confidence interval for P1 minus P2, 95% confidence interval, would look sort of like our earlier P tilde approach. What's the difference of P1 tilde and P2 tilde? P1 tilde is an estimate of P1. P2 tilde is an estimate of P2. And rather than adding 2 in the numerator and 2 in the denominator, this method of estimation, the Agresti-Cool estimator, again, via solving a quadratic equation, like in chapter 9, we add 1 in the numerator and then 2 in the denominator. Okay, plus minus 2 standard errors, and that standard error has a form which we can easily implement, because it's just a plug and chug problem at this point in time. Okay, so here we've got our data on Zenecal and then fecal urgency, if you will. The rate of fecal urgency in the Zenecal taking row, if we use the P tilde approach, it's 356 cases plus 1. Over 1913, total individuals trying Zenecal plus 2 faked data points, 1 success, 1 failure. We get 18.6%. Similarly, P2, we've got P2 tilde, 6.7%. Easy to do. Let's go ahead and implement the procedure then. Okay, my confidence interval for P1 minus P2 is again the difference of the sample-based estimates plus or minus the standard error times a z-value that goes with 95% confidence. In our case, and I'm going to say I got plus or minus 0.022, 11.9 plus or minus 0.022. Now I'd say pause and make sure that you get this exact same number. And if you don't get this exact same number, that's an issue. Common mistakes would be forgetting to take a square root, or perhaps taking a square root of each of the separate sections and then adding them before multiplying by 1.96. Again, not quite right. And I want to note while you're while you're sort of thinking this one through a little bit, I want to note that if you add the 1 in the numerator and the 2 in the denominator, if your sample sizes are really huge, like 1500 and 1600, it just hardly matters. Okay, we would have about the same exact P1 hat and P2 hat as P1 tilde and P2 tilde. So I'm thinking it doesn't matter if the sample size is large, but if the sample size is small, the tilde approach is definitely superior. So how do we get to an interpretation? Well, I think an interpretation is a good thing. I'm 95% sure that something is in the range 0.097 to 0.141. 0.097 to 0.141 is my margin of error, add and subtracted around my estimate, 0.119. So I'd say, well, P1 minus P2, I'm 95% sure that P2 is 0.097 to 0.141, lower than P1 is. I'm sorry, P1 is that distance higher, so about 10 to 14% higher. Now, when I say 10 to 14% higher, that can be confusing, because typically if I say one proportion is 10 to 14% higher, I'm using a ratio, and I get a ratio of 1.1 to 1.14. No. What we mean here is the difference of the two, okay? The difference of the two. And so I like to express it the following way. Supposing there are 1,000 individuals who are taking Xenical, and suppose there's 1,000 individuals who are taking the placebo. Okay, I'm saying typically there would be 97 to 141 more cases of fecal urgency in the Xenical taking than in the placebo taking group. Okay, so cases per 1,000. I'm literally going to multiply these numbers, the estimate and the margin of error, by 1,000, and I'm going to say that's how many more cases per 1,000 you have. You got 97 to 141 more cases of fecal urgency per 1,000 people taking the medication. That's not too bad. It's very doable. I think the interpretation is just express that range and say how many more cases per 1,000 you get. Let's try another example. Aspirin and heart attacks. Okay, and this is again in a group of elderly women who were with heart disease. About 11,000 each were assigned to take aspirin or a placebo. Our chi-square is large. We've looked at that data before. The p-value is small. There's definitely a relationship, and that's the directional p-value, 0.00005. Okay. My P1 tilde, my P2 tilde are easily calculatable. Okay, so my confidence interval is again a plug and chug, and if you didn't get the first one right, pause now and verify that you can get it currently. Okay, again, so if you didn't get that right the first time, I'd say take the opportunity and verify that you could get it right now. Okay, so now that you've gotten that margin of error, if you will, I'm going to sort of add and subtract the 0.003 from 0.0077. So that's 0.0047 up to 0.0107. So 47 and 107. If I were to multiply by, in this case, 10,000, I'd say 4 every 10,000. So for every 10,000 individuals, and I should say elderly women who have a history of heart disease, for every 10,000 elderly women with a history of heart disease, I can't pronounce that, but for every 10,000 elderly women with a history of heart disease, if they take a daily aspirin, and that's on the order of 75 to 100 milligrams. The typical amount you find in the grocery store these days is 83 milligrams. So that's based on studies like this. If they take a daily aspirin, you'd say you would have 47 to 107 fewer heart attacks, myocardial infarctions. Okay, so again, take our range of numbers, multiply by a large value like 10,000 or 100,000 or 1,000,000 or maybe in the earlier example, 1,000, okay? And tell me how many more cases you have. So 47 to 107 fewer heart attacks if you take the daily aspirin. I like that. It's a good thing. Okay. So that's just one way of tackling the problem of what is the relationship between aspirin and placebo. Let's try with a slightly different approach, a relative risk, and then with an odds ratio. Actually, relative risk, increased risk, and then an odds ratio. So let's get after the relative risk first. Okay, we're going to define the relative risk the following way. If I tell you the risk in the first row and the risk in the second row, you could say, aha, I'll take a ratio of those two numbers. Okay, the relative risk is the ratio of the two rates, if you will. Now, in our table here, I always, or I usually have the row is corresponding to the explanatory variable. So for example, are you taking aspirin or are you taking the placebo? That is the explanatory variable, and the column is corresponding to whether you have a heart attack. And I usually put the column which describes the outcome of interest to me in the left side. So P1 is the risk of a heart attack if you are taking the placebo, top row, risk of the event of interest. P2 is the risk of the event of interest in the second row, the in the aspirin taking row in this case. So my relative risk is P1 over P2. It's 0.0171 over 0.0094, 1.82. So there you go. My relative risk is 1.82. So I would say the following. P1 hat is equal to 1.82 times P2 hat. So in other words, the risk in the placebo group is 1.82 times the risk in the aspirin taking group. If you switch from taking aspirin to taking the placebo, you have your risk of a heart attack multiplied by 1.82, or if I were to express this with an increased risk, which is more natural, I'd say 82% higher. The risk of a heart attack is 82% higher in the placebo group than in the aspirin taking group. Okay, so the relative risk, RR, okay, typically we express the results in terms of the increased risk. IR is equal to 1, I guess the relative risk minus 1, times then 100%. In our case here, we've got 1.82 minus 1 times 100%. That's 0.82 times 100%, 82%. It tells us how much higher the risk is in the one group than in the other. The aspirin taking group has the lower risk of heart attack, and then the placebo taking group is 82% higher. There is a margin of error for the relative risk and also thus for the increased risk. It's not found in our textbook. If any of you care, I could look it up for you. Our textbook prefers a different approach to getting after the relative risk confidence interval than a straightforward confidence interval. It goes around via a back door. So I'm just going to say, if you could tell me this relative risk and then interpret the increased risk, you're in good shape. Okay, so I'm going to pause there, and we're going to come back and talk about odds next time.